We're going to talk about SQL Views. This is a very important element of a robust SQL database. A view is basically a way to abstract out some of the details of the underlying table structure in a relational database for a variety of reasons that we're going to try to allude to throughout this presentation. An example of a view, let me just take a sort of mundane example from the e-commerce domain. So if we have an e-commerce system that's tracking, for example, purchases by customers of products, we may well want to have reporting on that information that could be used by our sales staff or our ordering people to make sure we bring stuff into stock and so forth. But if you think about it just kind of informally, the report that would tell us about what's been sold to whom and so forth is going to be the result of joining together a variety of tables. We might have to join the product table with the order table, with the catalog table, with the customer table, or whatever. And because that's going to be something that we're going to probably do fairly regularly and maybe in several parts of our system, rather than duplicating the actual underlying table operations in the corresponding SQL select statement, we could actually create what's going to be called a view that provides the underlying functionality of that select statement, but it encapsulates it in such a way that we can just refer to that view and the table that results in that view as a coherent entity all on its own that can be reused and modified and queried from in a way that's very similar to using the underlying tables. The documentation for Postgres defines a view fairly comprehensively, and I want to just walk through this a little bit to give you an idea about what other kinds of things we can do with a view and why we might care. So, of course, they say it's an aspect of good SQL database design, and as I've just suggested, one reason to use a view would be to encapsulate a commonly used query in a way that would allow us to reuse that elsewhere in our system without having to redefine it multiple times. That's actually a specific example of what we might see more broadly as encapsulation. This is something that you may have encountered before in, for example, an object-oriented programming language where you can encapsulate the specific implementation of an algorithm behind a method. And you can have multiple instances of that method. You can have multiple classes that implement that method, and they can all encapsulate the behavior of that method behind the method itself. From the outside, we don't really need to care how that encapsulation does its job, how that method works for a specific class. In the same way, we don't have to care so much about how a particular query works behind the scenes inside of a view, because the view encapsulates it and allows us to use it without the guilty knowledge of what's taking place under the hood. One of the neat things about that is it lets us evolve the table structure without compromising the functionality of the views. So if we define these views as kind of a wrapper around a more detailed query using the actual tables in the database, we can then write our application code or our custom queries to rely on the views instead of having to know the details of what's going on behind the scenes. That allows us to make changes to the underlying table structure as necessary as the data model evolves and re-implement those views in terms of the new table structure, but with the view presenting the same consistent interface to the rest of the system. We'll also see that we can use views pretty much anywhere we can use a table, and we'll talk about some of the caveats to that. And it's also true that we can use views that use views. So the view presents the table abstraction just like normal tables do, and because views present a table abstraction, we can make views on top of those views just like we can create views on top of tables. So it's a very flexible mechanism as well. Let's take a look at a really basic view. We're going to talk about the create view statement. Because it's a create, you can tell that this is part of the SQL data definition language, right? Create, alter, and drop. And we're going to create a view here. If we just look at the bottom portion of this slide, it's exactly an ordinary select statement. It's going to give us the first name, last name, and title of the actors and the films that they're in by joining together the actor table, the film actor table, and the film table. The only thing that's new here really is this first line that's creating a new view. So create view, and we're creating a view called actor in film, and the as just says the definition follows. What this is going to do is add to our database a definition of a view called actor in film that behaves exactly like the select statement that's used to define that view. It's no more and no less than that. Let's take a look at how we use this. So here's a select statement, select star, right? Give me all of the fields in the underlying table from actor in film. Now this is the normal spot where we would typically see the name of a table in a regular select statement. And in fact, that's exactly the way SQL treats it, because we've defined our view in terms of a table, right? Because remember that it's tables all the way down. So this select statement returns a table that joins together three other tables. But that means that actor in film is effectively created and treated as a table throughout the database. So we can go ahead and make a query against that table just like we can any other table. In this case, I'm also adding this little limit clause just to keep the number of results reasonable to fit on the slide. But you can see that the result here is the first name, the last name, and the title of the underlying tables, because we defined the view to have those three columns, right? Those are the columns of the table. The rows of the table are going to be the ones that are determined by doing that three-way table join. And then we get the result as we would expect. We can also do alter on that view using the alter view statement. This is one simple example of that. Once we've created it, it's now persistent in the database. The definition of that view is there, and we can reuse it and refer to it as we've just done. I can say that I want to alter this view, the actor in film view, and I want to rename it to where have we seen her before? Every time we watch a movie at my house, we see an actor or an actress and think, wow, where have we seen her before? But that might be something we could answer with this list of actors and the films that they're in. So at that point, we can now do that same query, except now our view is called where have we seen her before, and we see that the results are exactly the same. Again, this isn't that earth-shattering, but it highlights the notion that the view itself is defined and stored persistently in the database. It's now a real thing in the relational database management system that we can then refer to and make changes to and so forth. And then finally, we can also drop a view, and this is, again, the third common command that's used in the data definition language. And since we've now renamed that view to where have we seen her before, this would be the syntax of the drop. And after that point, we no longer have access to that view. It's important to keep in mind that even though we might drop the view that was dependent on those three tables that we used in the definition of the view, the create view statement, we are not deleting the underlying tables. Again, if you think of the view as kind of a facade on top of the other tables that it's defined in terms of, we're basically just dropping that facade, that extra layer of abstraction on top of the tables. The tables themselves remain in the database intact as you would expect. So far we've been talking about using views as a mechanism for querying the database, but we can also use it to modify the data in the database, and that's the subject of updatable views. So we can, in fact, use views to update the table that underlies a view, but there are some conditions associated with that. First of all, the underlying query that defines the view has to have just one entry in the from clause. So it's got to basically be just a single table or another updatable view, which has the same constraint. We also can't do anything really very fancy in the underlying query. So although we can define a view that uses these things like group by and having and limit and so forth, we can't use that view for updating. And then finally, the view itself can't be defined to use aggregation. So we can't be using sum or count or average or min or max in the select clause of the defining view statement. Again, for all these conditions, we can still define views that use these different things. They can be table joins, they can have these different aggregation things and having and so forth. That's totally fine, but we can only use them for retrieving data. If we use any of these things, we can't use that view to do an update to the underlying data. And then what happens when we use a view that satisfies all of these conditions is that when we do an update operation in insert or update or delete through that view, the database will sort of convert the corresponding statement into the appropriate SQL to update the underlying table. So let's illustrate that by using this very simple view. Again, using the create view statement, giving it a view name, and then the as keyword introduces the definition of the view. And this is just a simple select statement that grabs the city and the country ID from the city table, and it constrains the country ID to be 103, which I cheated and looked behind the scenes and saw that that was the US. So this gives us access to cities in the US. Notice that we only have one table that we're querying against, and that I'm not using any of the fancy things that I mentioned on the previous page. So when we run this view with just the select statement, select star again to get all of the fields from that view, and then I've got some ordering and limiting going on here just to display it for you. You can see that we get a list of cities and countries, and of course the country ID is always going to be 103 because that's the way the underlying view is defined. We can also use this view to do updates to the database. So here's insert into USA cities, and then I'm listing the particular fields within that view that I want to update, and then supplying the values. I guess strictly speaking, Upland is not a city because we don't have a mayor. So this is a little bit fake, but whatever. So this is going to add Upland to that list. And you can see here in the result set that comes back, we now have Upland in the list, whereas previously we did not. So behind the scenes, what SQL was doing here is taking this insert statement and composing kind of the remaining elements of the insert by leveraging the definition of the underlying view. We don't have to say that we're working with the city table because USA cities is defined in terms of the city table in that from clause. Similarly, we can do a delete from that USA cities view in this fashion. So we're saying here we want to delete a row from USA cities, or we want to delete all the rows that satisfy this where clause. And we're specifying the row where the city is equal to Upland. And you can see in the output that Upland is now gone from this view, and it's gone because it's gone from the underlying city table. Now let's switch gears a little bit and look at materialized views. So what's a materialized view? Well, the views that we've been using so far, which we could just call normal views, will rerun the underlying query every time you use them. So for example, even if we're just doing a simple select against a view, what's going to happen when you run that select is that the select inside the view's definition is going to be executed if you do a select from the view itself. So we're sort of going fresh to the database every time we do that select against the view, and retrieving all of the information from the tables underlying the view, which is really the authoritative source for the data. In contrast, a materialized view is actually going to cache the results of an earlier access to the data through that view. And when you access the data again in the future, you're going to get those cached results. It's not necessarily going to go to the underlying tables to fetch in the latest and greatest data from that authoritative source. Now, why would we want to do this? Well, because it kind of seems like we're setting ourselves up for failure, because if we fail to update the materialized view from the underlying data, we're going to get sort of the wrong stuff. We're going to get old data potentially. So that is a risk of using this. However, there's also a benefit, right? It gives you faster access to the underlying data. So if the data that underlies the view is very time consuming to query, because multi-table joins or lots of data rows or whatever, you can avoid having to pay the price of doing the query again and just access the data that had previously been cached against that materialized view. It's also going to be the case that if you have underlying data that doesn't change very often and you want to just make it more convenient to access the data rapidly, a materialized view might be exactly the right approach. Let's see how we define a materialized view. The statement is quite similar to the ordinary view, so we're going to say create view, but we're going to add this keyword materialized, and then we define the underlying query as before. There's a little additional wrinkle here at the end of this statement I've put in with no data. Now, if you write the query in that way, or write this create view statement in that way, it'll create the view, but it will leave the view unpopulated. In other words, it won't go and do the underlying query and cache the data in the materialized view. You can also say with data, leave the no out, and that will cause the opposite behavior. It'll define the materialized view, and it will also run the query, this select in this case, bring in the data from the underlying city table and store it in the materialized view. The default behavior, if you just leave this clause off altogether, is to do the second thing. It will actually cache the data. However, for this example, I intentionally wanted to leave that with no data there, because I want to illustrate what happens if we don't have the data cached in the materialized view and we try to query it. And that's what's shown next. So again, I'm just using the select statement, selecting all the fields from that materialized view that I've just created. And in this case, we get an error message back from the database. It says Materialized View USA Materialized Cities has not been populated. And then it actually gives you a little hint here to say refresh Materialized View to get the data in there. So the behavior here is that it's totally up to you, or totally up to your application, to make sure that the Materialized View is actually populated with data. And if you fail to do that, the database itself has got your back. It's going to say, hey, sorry, I haven't gone out and refreshed the data. And the reason behind that is that the Materialized View doesn't want to assume for you that it's time to go out and fetch that data. It's entirely up to you and your application or your direct use of the database management system to determine when is the appropriate time to bring the data into the Materialized View, as opposed to just having the database make the assumption for you. So we're going to next turn to that refresh Materialized View command, and we can see here we're executing refresh the view. That's one statement here that's going to cache the data from the underlying query, and then I'm basically re-executing the query that I had on this previous slide that gave an error message before, but now it's going to actually give us the underlying city data as we'd seen previously. So again, it's up to you or your application to refresh the data in the Materialized View as necessary. If you want to, as I said previously, if you want to do that right from the beginning, you can leave this off or just leave the no part off, and it will tell it that when the Materialized View is being created, seed it with the data from the underlying table as of that point in time. I want to drive this point home that the Materialized View has its own copy of the data. So in the next slide, I'm going to insert Upland back into the database, but I'm not going to do it through the view. I'm just going to go to the underlying table, right? I'm going to directly to the city table, and I'm going to insert that new value in there. And then I'm going to run a select statement, again, to see what's going on in the underlying table itself. And as expected, we see that Upland has reappeared in our city table. Now let's go and check the same result from the Materialized View. So here's the same query we were running before, except now we're going to get from the Materialized Views cities, and we'll see here that Upland is not in the view, right? These changes that we just made are not reflected automatically in the Materialized View. We've got to go and ask for those changes to be refreshed into our Materialized View. So again, if we go back and rerun that same refresh Materialized View command, and then run the query against the view this time, we'll see that the value Upland has been restored to that Materialized View. But again, we have to do that manually. We've got to run that refresh in order to update the cached version of the data in the Materialized View. Here's some links to various resources in the documentation for Postgres, as well as a link to that really helpful Postgres tutorial that discusses more about how to use views in detail.